In this lecture, we are going to introduce to the concept of strings in C. We are going to learn how is string represented in a computer's memory and how we take the input and output for a string. So let's get started. So first of all, let's look at this statement printf hello. In this statement, you see hello is enclosed in the double quotes. So we say this hello is a string, right? String is the sequence of characters that is enclosed inside a double quotes. Okay, so hello qualifies to be called as a string. Okay, now let's talk about how is a string stored in the computer's memory. As we have already discussed that a string is nothing but a collection of characters, so it must be stored as an array inside the computer's memory. So understand this in more details, let's talk about something called as character array. Now character array is nothing but it's a collection of characters. Now let me create a character array to store this string hello. Okay, so because this is a character array, so I'll have to start with this keyword char representing the character data type. Let's say name of the array is A and let's say the size is 5. It has 5 characters. Hello has 5 characters. So I open the braces like this, okay, and give a semicolon at the end. Now each character is presented here, okay, and each character is enclosed in a single quote H, comma, first character is H, second character is E, third character is L, fourth character is L, and the last character is O. Okay, now this is my character array. Now inside the computer's memory, it will be stored starting from index 0. Okay, this is index 0, index 1, index 2, index 3, and index 4. Now this character array is represented by the name A, and it has 5 indexes starting from index 0 to index 4. So H is going to be stored in the index 0, E in index 1, L in index 2, L in index 3, and finally O in index 4. This is my character array. Okay, now character array is quite simple. It's just the collection of characters. But a string is something different. It's something more to the character array. Okay, now let's try to represent the string hello in the character array. So let me have a character array here called as B. Let me not provide the size here, and then I write equals to, and in double quotes I'll write hello, HELLO. Okay, so this is allowed in C. Okay, so here I have not provided this size. It is not required. By looking at this string hello, it will decide, the compiler will decide on the size. Okay, now if you look at this B, how is B going to be stored in the memory? Let's write it down here. Okay, this is B. Now at index 0 you'll have H stored. Okay, at index 1 you'll have E stored. At index 2 you'll have L stored. At index 3 you'll have one more L stored, and index 4 you'll have O stored. So it looks exactly like the character array A, but there will be one more character stored at the very end, okay, at index 5. That is called as the null character, represented by \0. Okay, this is in a single quote. So \0 in a single quote, this is called as the null character. Okay, null character is the character that represents the end of the string. So this represents the end. Okay, this means whatever comes before this is the part of the string, and whatever comes after null character is not relevant to us for this particular string. Okay, so we say that a string is a character array which ends with a specific character, that is the null character. Okay, so we say B is a string but A is not a string, because in A it is not ending with a null character. At end, if I append something here at index 5 and make it to store the null character, then it becomes a string. Okay, so we can say that all strings are the character array, because see, look at, this is a string, right? This is a string B. All these are characters, sequence of characters. This is also escape character. This is called as escape sequence. Okay, null character. This represents the end of this string, right? So this is a sequence of characters. So this string is a character array, right? So we can say that all strings are character array, but all character array may not be a string. So this is a character array. This is not a string because it is not ending with a null character. But if I have one more character here, let's say I make the size as 6. Okay, and here I write \0 at the end. Okay, so this is \0 and enclosed in a single quote. Now this becomes a string. This character array now becomes the string. Okay, now there's one more concept of length. So what is the length of this string? Length is the number of characters in the string excluding the null character. Okay, so in this case the length is 1, 2, 3, 4, 5. So we say the length of this string is 5. Now let me create one character array C. Okay, C, I do not give the size, and inside the double quotes I'll write hi high. So how many characters I stored inside the computer memory? It is 3 characters. One is H, other one is I, and the last one is the null character. But what is the length of this string C? The length is nothing but 2. The valid characters are H and I, so the length is 2, but in the memory it will occupy 3 spaces, 1 space for the null character. Okay, automatically null character will be appended whenever you give the string inside the double quotes. Okay, so this is the basics of the string. Now let us summarize the definition of string. What is a string? A string is nothing but a character array, that is the collection of characters, always ending with a null character. Null character is represented by \0, that is in a single quote. This is a null character. So if any character array is ending with a null character, that qualifies to be called as a string. So let's look at this, all these character array, right? So first character array A. Now is this a string? This is not a string because it is not ending with a null character. I have 2 characters here, H and I, but there is no null character present in this. So this is a character array, but it is not a string. What about B? In B, the size is 3. Right, so there are 3 elements, 1, 2, 3, and the last element is the null character. So this qualifies to be called as a string. So I say that B, character array B is a string. Okay, what about C? In C, I have not given the size. It's okay, I can avoid giving the size. Here I have given the string high in double quotes. That means automatically the null character is appended at the end. So this qualifies to be called as a string. Whatever comes inside the double quotes is a string. Let's talk about D. Character array D is again having high. Okay, it's the same as C, right? So this is also a string, there's no doubt in this. Okay, but if I now give the size here as 2, let's make D 2. Whenever I make D 2, I am confining myself with 2 characters. I have just 2 characters in D. The first character is H and the second character is I. Now the compiler will not get any valid space for storing the null character because I have fixed the size to be 2. So in this case, this may not be qualified as a string, right? So this is a location wherein null character is not guaranteed, right? So because the size is limited to 2. So in this case, I say that this is not a string whenever I make 2 as the size, because I have to have one more size. I have to have it as 3. In that case, null character will be appended automatically because here size is limited. Therefore, this does not qualify to be called as a string. What about the character array E? In character array E, you see there are 5 characters, 1, 2, 3, 4, 5. That's okay, right? I've got the null character here at the index 2. Okay, at index 2 I've got this null character, right? So I say this is the end of my string. So I say E is a valid string, right? But what is there in E? In E, I say there is this string called as high. Okay, I am not bothered about what is coming after the null character because this represents the end of my string. Okay, so this string, actually the length of this string is 2 because there are just 2 characters just before the null character. So whenever I encounter the null character, I do not bother about what is there after this null character. Okay, so the length of this string E is 2 and this qualifies to be called as a string. Okay, so now let's try to write a computer program to demonstrate strings. Let's try to see how we can take the input as a string and how we can output this string. Okay, so let's get started. In this program, if you see at line number 7, we have defined this string. Name of this string is str and the size of this string is 10. That means it can hold maximum of 10 characters in this string. So let us try to take the input for the string, right? So string has the format specifier. The format specifier string is %s. Okay, so if I have to take the input for this string, what I do is I'll just simply write, first of all, let me write printf, enter your string. This is the message that I'm trying to provide to the user to enter this string, right? So how do I scan this string is I can use this scanf function, scanf, okay? %s is the format specifier for a string and I give comma and I just give the name of the string. Name of the string here is str and I do not write ampersand here. Okay, whenever you are taking the string as the input, there is no need to write ampersand because str itself is the address of that particular string. So ampersand is not required whenever you are taking the string using the %s format specifier. Okay, so here just note it down. Okay, ampersand is not required, Okay, Now this is how you scan the string. And how do you display or how do you output this string? It's very simple. I'll write printf your string is, okay, I'll write %s is the format specifier. I give a new line and then I give comma and then I write str, okay, name of the string. Okay, it's very simple. So let me try to compile this code and see if it works fine. Okay, so let's write gcc string demo.c, no error. So let's run this now, a.exe. okay, you see enter your string. So let me write hello and the output is your string is hello. It works fine. Okay, now let me try with one more input. Let me write hello space hi. So I'm giving the string separated by a space. So a string is having hello and space and then hi. Enter. Output must be hello hi, but it is here displayed only as hello. That means scanf is only taking the string until it finds a space. Okay, whatever is after the space is not taken as the input. So this is the drawback of taking the input using scanf %s format specifier, because in this case it will only input the string until it finds the first space character. So let me try with one more. Let's write hi, hi, hi 3 times. So it will only take the first hi, because after first hi it is going to encounter this space. So it is not going to take the characters after this space, right? And so if I enter, you just see hi. Okay, so it is going to take all these 3 characters and this space character is going to be replaced by the null character. So you have this hi and then null character stored in the memory, right? So it is going to display hi and it is not going to display other hi that I have inputted from the terminal. Okay, so this is the drawback of taking the string using the %s format specifier. So if you want to take the string having this space also, right, in that case what you have to do is you'll have to use the function called as getS. So getS is a function that is defined in stdio.s. They'll help us to take this string as an input. So I'll write getS str. So str is where I'm going to store my string. No need to give ampersand here, right? And then let's try to now compile this code. Okay, so compilation is successful. a.exe. So let's run it. Enter your string. So I write hi space hi space hi, and the output is hi space hi space hi. Okay, so this is working fine. Okay, so whenever you have to take a string that is having multiple words separated by space, in that case you'll have to use the getS function. Okay, so you can give any input for that matter. Let me write C space program, right? The output is C space program. Okay, using getS function you can input any sort of a string from the user. Okay, so this is the getS function. Now getS function works fine in most of the cases, but getS function is having some drawback. It is sometimes dangerous to use getS function, which we are going to talk about this in our subsequent lecture, right? But instead of getS, we are supposed to use this one more function called as fgetS. So this is the better version of getS, fgetS. So this function fgetS fixes all the drawbacks of getS function. So therefore it is suggested that you use fgetS function, which we are going to introduce in the next lecture. Okay, so that's all in this lecture. In this lecture you have learned what is a string, how is a string different from the character array. Okay, and then we have seen how is a string represented in the computer's memory, how you can take the string as an input using the scanf function, and what is the drawback of taking the string using the scanf function %s format specifier, right? And then how that is solved by the getS function. And then we have finally noted down that getS function is dangerous to use. So therefore we are going to use a newer version of getS function called as fgetS that we are going to learn in the subsequent lecture. That's all in this lecture. Stay tuned.